mass 40,000 kg docks with a space station of mass 160,000 kg. The spacecraft is traveling at 200 meters per second immediately before docking takes place, and the space station is traveling at 200 meters per second. The docking is modeled by two particles moving in the same direction. Okay, so moving in the same direction. So I can draw this. Okay, one particle, and then okay, another particle. Okay, moving in the same direction. So the docking is modeled by moving at its same direction, straight line that collide and coalesce. Okay, coalesce means they attach together. Okay, so now the spacecraft is traveling, okay, at the speed of 202 meters per second. Okay, that's the V, and then space station is traveling at 200 meters per second, but the mass of spacecraft is 40,000 and the mass of space station is 160,000. Okay, both in kg. Okay, so now after docking, what happened is they collide and then they coalesce. Coalesce means they attach together and then they move together. So both move together. So plus B. So both I can treat it as one entity. Okay, one particle. Okay, so now let's find out what is the momentum before collision. Okay, momentum before collision, quite straightforward. 202 multiplied by 40,000, okay, plus 160,000 times 200. And since both are moving at the same direction, no sign need to change here because I keep towards right as positive. Okay, so this is before collision. And after collision, what happened is both attach together. Okay, and 40,000, okay, it coalesce, so they attach, plus 160,000. Okay, when they coalesce, meaning they are joining together. Okay, or joining because of the collision. Sometimes we have seen due to collision, you will see that two vehicles are attached together. Basically they'll be moving together for a certain short distance before they stop. So that's what happens. So over here, so they coalesce. So when they coalesce, both becomes together one, and so you need to add the mass of spacecraft and the space station and then multiply by the velocity. Okay, so the velocity, calculate the exact velocity of the spacecraft and the space station after the docking. Okay, once they dock, they become together and then they're moving in the same direction. Okay, now let's do this. So 202 times by 40,000 and then 160,000 times by 200. So over here, what we have here is 808,000 plus 320,12345. Okay, and this will give us 200,000 times V. Okay, 200,000 times V. So from here we have 4008,000 equals to 200,000 V. So V equals to 200.4 meter per second. Total loss in kinetic energy during the docking. Okay, to find the total loss, we have to find, before that we have to find what is the total kinetic energy before docking, and then we find separately after docking. After docking, what happened is they coalesce. Okay, meaning they join together. So we got to do it separately and then subtract these two, and from there we can find what is the amount of loss. Okay, kinetic energy formula for Ke is half times by mv square. Okay, half times by mv square. So half multiplied by m, okay, Okay, M for the spaceship, which is 40,000. Okay, sorry, spacecraft is 40,000. Okay, multiply by the initial speed, which is 202, and square that. Okay, this is for spacecraft. CRAFT, spacecraft, plus this is before collision. What is the KE for space station? Okay, so space station, again, half mv square. So in this case, what I have to do is half multiplied by the mass of the space station, which is 260,000. Yeah, 160,000, multiplied by the velocity or the speed, which is 200. Okay, 200 square. So this is for space station. Okay, for space station. Now what I have here is, when I multiply these two and then add them together, I have 401,608,0000 joule. Okay, so use your calculator to check, and this is what I have. Now let's find out what is after the docking. Okay, after docking. So after docking, we have they join together, so I have 200,000 as their mass. So the KE will be half mv square, which is half times by 200,000 multiplied by v, the velocity, which is 200.4. So 200.4 square. What I've gotten here is 401601600. So therefore, before collision, okay, before docking, and this is after docking. So KE loss, okay, will be before minus after. Okay, so 401,608,000 joule minus 401,601,6000, and the answer is 64,000 joule.